Welcome to Winnimatics, where mathematics is simplified. I remain yours, Winifred. If you are new to this channel or you are yet to subscribe, click subscribe now. Click on it. Have you done that? Well done. And equally click on the notification bell so that you'll be notified whenever we upload new videos. Alright, if you have not watched the video on the addition and subtraction of binary, you need that knowledge. You really need that knowledge before this one. So I would advise you to pause this and go and watch that one. Watch the addition and subtraction of binary before you come to this one, so that you will have a perfect understanding of what we are going to do here. Okay, so in this video, we'll be looking at multiplication and division of binary number. It's very simple, just like the addition and subtraction we did in the other video. It's very simple, and like what we have in the other video, 6 questions. So we have 6 questions here, 3 for multiplication and 3 for division. So as usual, I'm going to answer 4. Yes, 4 out of these 6. And then leave the remaining 2 for you to use as your assignment. Okay, so which one will I leave for you now? Let me answer. Okay, I will answer 1, 1 and 3. How about that? Sorry, let me not put asterisk. I will leave 2 for you. So I will answer 1 and 3. Will you do 2? It's okay, right? Don't worry about it. I explain 1 and 3. We see how simple it is. You will now use the pattern and the method to answer 2. Then for the division, let me leave 5 for you. I'll answer 4 and 6. I think it's okay. It's fair enough, right? Okay, so let's start. For the multiplication, so we're starting with 1. 1001 base 2 times 11. They are all in base 2. So we start the normal multiplication. 1 times 1 is 1. 1 times 0, 0. 1 times 0, 0. 1 times 1, 1. We go to the second one. 1 times 1, 1. We're going to write it under the second one. 1. 1 times 0, 0. 1 times 0, 0. And 1 times 1, 1. So we now add this like we do in normal multiplication of decimals. So we add this. So you see why I said you need to watch the addition and subtraction video so you understand what we're here. For the multiplication, we'll be working with multiplication and addition, so you need knowledge of addition to understand the multiplication. So let's see. 1, nothing is here, so I'll bring down 1. 0 plus 1 is 1. They are all less than 2, that's why we're writing it. 0 plus 0 is 0. 1 plus 0 is 1. Then we bring down this 1. So we have 1, 1, 0, 1, 1 base 2. If you remember what I said in our number basis, the video on number basis, that binary numbers contain only zeros and ones. So if you look at it, you see that it's only zeros and one that you're seeing to show us that this is actually binary numbers. Okay? Is that clear? Alright, copy done. Make sure you're writing. I will answer 3. 1, 1, 1, 1 times 1, 1, 0 times. Start. 0 times 1. 0 times 1 is 0. 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 1 times 1, 1. We're going to write it under this second digit 1. 1 times 1, 1. 1 times 1, 1. 1 times 1, 1. And we go to the third one. 1 times 1, 1. We write it under this 1. 1 times 1, 1. 1 times 1, 1. And 1 times 1, 1. Then we add. This 0, nothing is here, so we bring down the 0. 0 plus 1 is 1. 1 plus 1 is 2. You remember what we did we said in the video on addition and subtraction. So 1 plus 1 is 2. See that 2 here? Because we're working on base 2, so we're going to have 2. How many times will 2 go in 2? How many 2 do we have in 2? Is 1, 1, remainder 0. So this remainder, we write it. This 1, we carry it to this 1. 1 plus 0 is 1. Plus 1, 2, plus 1, 3. So I have 3. 3 over 2 because we're working in binary. How many 2 can we get in 3? It's 1, 1, remainder 1, right? So this remainder, we put it here. This 1, we give it to this. 1 plus 1 plus 1 will give us 3. So if you do the same thing, 3 in 2 and 2 in 3, so we have 1, 1, remainder 1. So the remainder, we write. This one, we put it here. 1 plus 1 gives us 2. So we do what we did here for 2. 2 in 2 is 1, 1, remainder 0. So we write the remainder 0. And since that 1 we carried, since nowhere to give it to, we bring it down 1. So we have this 1, 0, 1, 1, 0, 1, 0 is 2. Very simple, right? Yes, it's very, very simple. So use this method. Use this explanation and attempt question 2. You see the correct answer on the screen. So when you solve yours, check if it is the same with our answer. If it is, then good news. But if it's not, try again, you get it. Okay, good. All right, let's now quickly look at division of binary. Very simple. Division of binary numbers. Division of binary numbers. So for division of binary number, we'll be needing knowledge of subtraction of binary, just like we used the knowledge of addition for multiplication. So for division, we'll be needing subtraction. All right, let's start. Okay, I said I'll answer 4 and 6, then 5 is for your assignment. Is it right? It's okay. Okay, so let's start. 4. So the normal division will be used in non-division method. There are methods of doing this. You can decide to change this to base 10, change this to base 10, so it will be like the normal number you know, divide it, the answer you get, you take it back to binary. You can decide to use that method, but I don't want to use that method. I want to use this one that is very short and simple. So let's start. This is 1, 0, 0, 1. We are dividing by 1, 1. Remember they are in base 2. This is how we do base 2. Okay, so this is 1, 1. It's 2 digits. 1, 1. The 2 digits is here. This is the 2 digits. But 1, 0 is smaller than 1, 1. So because it's smaller than 1, 1, we have to extend it to the third digit so that we will have a number that is big enough for this one to go into. Is that clear? Okay, so 1, 1 can it divide 1, 0, 0? Yes, it can, because this number is bigger than it, so it means it can. So our own is can it or cannot. If it can, 1. If it cannot, 0. So since 1, 1 can divide 1, 0, 0, we have 1. I hope you're following me. So our own, yes, carries 1, no, carries 0. So you don't need to divide the normal division that you know. Your own is, can it divide it? Is it big enough for it to go? If it is big enough for it to go, 1. If it is not big enough for it to go, 0. So 1, 0, 0. Can I let 1, 1 go in 1, 0, 0? Yes. So that yes has 1. Is that clear? It's very simple. So 1 times 1, 1, you get 1, 1. So we now, here is where we are going to use the knowledge of subtraction. We subtract. Remember, our target is 1, 2, 3. It's the 3 digits. This one we're not touching to. We don't have anything to do with it for now. So we have 1, 0, 0, subtracting 1, 1. So the normal way we did in the subtraction, 0 minus 1 will not go. The neighbor doesn't have anything. So we'll go here and borrow. When you borrow, this reduced to 0. Give to this is 2. Borrow 1 from this, reduced to 1. Give to this is 2. So 2 minus 1 gives me 1. 1 minus 1, 0. And then 0. So our remainder is 1. Is that clear? Okay, so we can now go to the next one. Since we have a number that is remaining, bring it down. Bring down this one. So we have 1, 1. 1, 1 divided 1, 1 will give me 1. 1. 1 times this. When you subtract it, it will give you 0. So our answer is equal to 1, 1 base 2. It's very simple. Very, very simple. Just follow the methods, you will get it. If it can, 1. If it cannot, 0. So if you use it, it's very simple. Okay, let me answer 6. Just follow me very well on this 6. You will see the simplicity of this is very simple. Let's go. I hope you have written down this. Okay, so. Okay. So this I have 1, 1, 0, 0, 1, 0, 0, 0. We're dividing by 1, 0, 1. So we start, this has how many digits? 1, 2, 3. So we start with the 3, 1, 2, 3. Since it's big enough for it to put, so we start with this 1, 1, 0. So can 1, 0, 1 go in 1, 1, 0? Yes, because 1, 1, 0 is bigger than this, so it can actually go. So since it can, 1. 1 times 1, 0, 1 give me 1, 0, 1. You follow me? You subtract, minus. So 0 minus 1. Remember, we're dealing with the first 3 digits. These ones, we don't need them for now. So 0 minus 1, can it go? No, we borrow 1. The way we did, this will reduce to 0. Give it to this. Remember, since it's in binary, so whatever you borrow is 2. So this will be 2. 2 minus 1 is 1. 0 minus 0, 0. 1 minus 1, 0. Do you understand up to this? Okay, so our remainder is 1. The 0, 0, 1 is the same thing as 1. So we go to the next number, the next digit will bring it down. We bring it down, we have 1 and 0, right? You ask yourself, can 1, 0, 1 go in 1, 0? So 1, 0 is smaller than this. Since it cannot go, remember, yes, 1, no, 0. So can it go in 1, 0? No, so I'll put 0. Is that clear? So I can now ask the neighbor, please can you come down? To come down 1. So I have 1, 0, 1. Can 1, 0, 1 go in 1, 0, 1? Yes. So I'll put 1. 1 times 1, 0, 1. 1, 0, 1. So let's subtract. When you subtract this is 0, 0, 0. So everything here is 0. So you bring down the neighbor. The neighbor is 0. Can it go? No. 0. Bring down the neighbor. Can it go? No. 0. Bring down the neighbor. Can it go? No. 0. So nothing again is remaining. So this is my answer. Therefore, our answer is 1, 0, 1, 0, 0, 0 base 2. If you want to check if your answers are correct, what you can do is you can change this thing to decimal, that is to base 10. Change this one again to base 10. Do the normal division. Whatever answer you get as from your normal division, change it to binary, you see you get this. But this method I can assure you is very simple. Just go through this video over and over again, you will understand it. Once you master this, it's very simple to answer any kind of division on binary. So with the explanation of 4 and 6, use it to attempt 5. With the explanation of 1 and 3, use it to attempt 2. You will see the correct answers on the screen. When you finish solving yours, check if your answer is the same with mine. If it is the same, wonderful. If it is not, try again. Keep trying until you get it. You can also send us a message on our Instagram handle. You will see our Instagram handle there. So follow us. Send us message, tell us how the video has been helping you, and remember to share with your friends, especially those preparing for examination, so that they will have a perfect understanding of how operations of binary go. Alright, I remain yours, Winifred, and this is Winimatics, where mathematics is simplified. Bye bye.